Assalamu alaikum. Myself Mariam Ali. Today I am going to explain you about a line follower robot. So basically, the line follower robot here is a simple and easy robot which we form with muxes. Today I am going to explain you that how I design and build a simple line follower robot using muxes instead of using a microcontroller. So basically, this is a simple basic robot that follows a specific path indicated by a line, usually a black line on a light colored surface or a white surface, having some particular width. So the width of our arena is of about 1 inch. The main objective of forming this line follower robot is to form a robot which follows a specific path and obeys some specific commands by a simple process. So basically, for this project we use some simple 4 sensors and a multiplexer, 2 multiplexers. Further, what is the purpose of this line follower robot? So basically, the line follower robot is usually at high level. It is of great use in the industries that follows a particular line and do the specific work as they provide it. It is not necessary that a line follower robot have to follow black or either white line. Further colors can be formed by doing further processes. So basically, the whole project is based on this block diagram here shown. It is a motor module, 2 muxes, the 4 sensor. The main working of whole process here is these 4 sensors. These 4 sensors are the major portion which detect the line and forward the command the muxes. Muxes follow these commands the motor module left or either right, and these motor modules provide the direction to the right motor or left motor. The main here the function that doing to perform or run these motors is a motor module. In the motor module there are different portions to move it clockwise or to move it anti-clockwise. So by that we control the direction of our motors. Furthermore, for a selection of these projects as shown here clearly, so furthermore I have detailed that we use some muxes, IR sensor, some connecting wires and the main L298 motor drive module. Further, before going to this project, what is the body structure and mechanical structure of this whole? So this is a mechanical robot kit. It can be of 4 tires, 8 tires, or 3 tires or 2 tires. It is of different kind. But for our robot design, line follower robot design, we uses a 2 motors robot. So here are the simple things here, these, and there are steps that we took some here, the motor here, and further this is the whole car on which our further project placed. Furthermore, this is the arena here and this is a T line here. So the T line, there are different things the board have to form, board have to function. For whole this process we form a complete process right behind this. Before going to the process or explaining that how this robot work on this arena or follows a specific line, let's go to the components. Here Here are the first main component of our project, mux. So basically mux is we use a 8 cross 1 mux, one for the left motor and one for the right motor. So here it gets some 8 inputs in it and provide a single output. According to the 8 input, it provides a single output that the motor have to move left or right. Or in this that if a left sensor is on, then the right motor will work, and if the right sensor will on, then the left motor will work. Following this is a mux here. As simple multiplexer, we have to provide some 8 input and the 3 selection lines which control the whole inputs to get a single output here. Furthermore, these are the input configuration of our muxes which a hardware mux have. The main further component is the infrared sensor. So basically this infrared sensor is that the light will goes to an invisible light, radiations will goes to the line here, the black line, and which detect and back to the emitter, so it detects the light and provides whether it have to work further or not. So these are the 4 sensors, and we have the 4 sensors, the left, right, and the left center and the right center. For left to move left, right to move left, or the 2 center things provide for the U-turns or turns for the left turn or the right turns here. Onward, it is a LT98 motor module. So it is highly useful in different things as it is a DC motor and it supplies 2 channel here. This is the input. Here I am going to show you. Further I have the input pins of it. I will show there too. These are the 2 control here. We have to provide our motors positive negative terminal here. Further, this is the main supply here. One is the 5-volt thing, one is the positive, and one is the ground of the whole circuit. It is the H bridge here, and further it is a 5 voltage regulator. We have to provide from the backward. We can provide it high voltage, but further it provides all a small voltage of 5 volt. It is also used for the driving DC and step motors. Furthermore, let's get to the configuration pins of our sensors. So basically this is the IR sensor which I am talking about above. Here it have simple 3 pins here, and from the 1 pin is out as it is shown here clearly. If you can see that, one is the out pin, other is the ground, and third one is VCC. The ground and VCC are attached with the supply obviously, but the out pin is that what it is detecting. When it detects something, it passes here 1 in the binary. If we talk, it passes 1, and if we detect null, then it passes 0. Further, here are the IR sensor main thing. Number 1 thing is for the IR LED transmitter. So a transmitter IR light is invisible to us as its wavelength is much higher than the visible light range. Some transmitters have the range of kilometer. IR LED have a white or transparent color, so it gives so here. And there's a white light. This it is a transmitter, and this black LED it is a receiver here. Furthermore, there is a LM358 operational amplifier in it. Further, a variable resistor, or some kind of, we can do calibration to detect forward sensitivity. It is LM298, and for us check the sensitivity for the calibration, we do this so that it works properly either for the black line or either for the white line. Except for I have a lot of applications for obstacle detection, safety devices, wheel encoders, or many things. It just detects a thing if something is passing, and we have to adjust its calibration to detect either white or either black line. Furthermore, in our project, the main process is the lithium-ion batteries here. These are rechargeable batteries, and its maximum charge of this is about 4.2, but usually it is of 3.7 watt. Further, it as uses the two batteries, so it's combinedly form a 8.4 volt here. So furthermore, as for our wheels, as shown before, it's a DC motor, a simple DC motor this is, and having a speed of 1000 RPM and the voltage it can control is 5 volt to 12 volt. Above then that the motor will destroy it, of course. But onward, this is some speed, torque, and the power of our motor is here. As I told you before, let me show you the pins. In a software, it is looked like that, different softwares. So further, in reality, this is the pin out of this is the VCC. This is the ground. We provide here the voltage. These are the three S0, S1, and S2 selected lines by which our let me check this. By this, our the inputs control and give over a specific output. Here is the 5 and 6. So both are the output, but it provides the direct output. It provides the inverse of hex of output hex inverter. And this is the E enable. E enable is basically the thing have to provide that either the mux have to provide input or not. If it is at 0 state, then the further here as this 7451 here's enable pin else, but at 0 it is a low enable, and for the low enable the enable have to provide 0 so the circuit work. For the high enable we have to provide 1 for the circuit to work. I'm saying that the mux have to provide an input at 1 if it is a high enable mux, but it is a low enable mux, so it works at 0. Further, it is a NOT gate. NOT gate, a simple NOT gate will look like that, but as its IC is like this, so we have 6 NOT gate inside it. It provides here, further things. Onward is the LM298 motor driver. So basically, this is the whole thing here. It contains this. Here. This is the. We have to provide power, 12 volt, ground, and 5 power here. This is the enable here. So, and further, these are the 4 things here. If I can show you clearly, then these are the 4 enables. IN 1, 2, 3, and 4. According to that, one is the clockwise for the motor 1. It is also for the motor 1, but it is for the anti-clockwise. Then clockwise and then anti-clockwise for the 2 motors. So this is how it controls the speed of a motor. Furthermore, this is as the project is not from direct, so it is the old version at which our mux work. So, and this is the PCB circuit here that we have to do. Furthermore, the main requirements for our line follower hoverboard is that it have to take various turns where it is capable of. At arena, it have to take proper turns where it is provided and provide the function to it. Onward, the calibration of the light, as I already told you about the sensors have a calibration to adjust it for the light. Onward, for our project, we don't use Arduino, we use the muxes and the gate ICs. Mux for the 74151 and the gate as a NOT gate 7404. Further, we use a motor drive module L298 and a battery of a 12 volt lithium ion batteries. Further, this is the table on which our whole circuit works. This is the input here. This is the left, right, center left, center right. And this is the output left for the left motor and for the right motor. So basically, when all input are at 0, then the both motor are 0. But for the right here, now this is our car. Here is the left motor. Sorry, it is the right motor and it is a left motor. And the further, here are the 4 sensors. So basically onward, it is a left motor and it is the right motor here. So when the right sensor is on, now this right sensor, when right sensor is on, then this left motor will work. And when the left sensor is only on, then the right motor will work. There is a case also when only the left motor is on here. When the left sensor is on, then the right motor will work here. The further thing in this truth table are that here. What if not the right, not left? Only one. If a center left is on or either a center right is on. But the condition is that the left and the right have to be 0. So condition like that, 0, x and 0. This two can be of any state, but the one must have to be at 1. So in that condition, the both motor will work and the board will go straight here. Further, if center right and the right will on, then 1 will work. And similarly, if only the left and the center left will on, then the right motor will work here. Further, as I already told you, either the center left is on or either the center right is on sensor. Then our both motor will work and it goes into a straight line. Further, here is a center left and right is on. Now here the 4 sensor here. This sensor is on and this sensor is on. But for our condition, as the most superior is the right and the less superior is CL and CR, so the center left or center R. As the superior one is on, so we have to follow according to this condition that the right motor is at 1, the left motor will work here. Similarly, when the both will on, then the both motor will work here. Now here as shown, the left is off, but center left and center right both are on. But as I already told you that the right one and the left one has the superior here, so as the here also one is at the right, so the motor will move left, not the right. Onward, but if the both sensor will on, when the both sensors are on, then no motor will work here. The motor will stop. onward, if it have the left motor will on, the center right will at, let me clear it for the more clarity here. Furthermore, the will work as I already told you before. Left on, right on, so both motor will stop. If the left will on, the right it at center left, center right is 1. But the superior one is left, so the right motor will on. Onward, here the more both superior one are on, so the left and right both motor are at 0. Similarly at the case here, not here, because here the right is at 0, so the left motor sensor work, right motor will work. And at the end, the both all are 1, or either I can say that the left and the right both motor are on, so no motor will work. Furthermore, I have applied a rudimentary logic on this truth table instead of using a K-map, which is a long process. So what is a rudimentary logic here? So it is a logic that you have to form a 2 pairs like 0 1 1 1 1 1 0 0 S here. If we can see that 0 1, then it follows the right one, so it is R here. So for that it is this. Furthermore, this is the whole rudimentary logic work, and according to this rudimentary logic, these 4 inputs goes into the mux. This is our mux, so these 2 3 4 5 6 7 8, so these 4 input will goes there by using this R and a 0 1 and a NOT gate here. But further, where these L, CL and CR input goes, it goes into the selective line of a mux. From the least bit to the most bit. Further, this is a flowchart for a truth table of a sensor that a motor is start. Now we have provide the battery applied, so it is here. Now further, IR sensors. When it will start that the battery is provided to the circuit to the holder board, then the IR sensor will start working. Now IR sensor detects something, so it goes into the processing and provide them at the left mux or the right mux by using those someone input by these 4 sensors. Onward, they provide some 1 or 0 to this motor module, and the motor module then provide the input to the left motor or the right motor, that the either which one is at 1 state and which one is at 0 state. But if when this work, the further goes here or at the end, either it will stop or either it will go again to the sensor to detect something else. So this is the whole flowchart. Further, IR sensor here, and this is the schematic of a PCB layout. This is our PCB. Further is a 3D visualization here, and the final testing. This is our actual things. Array of IR sensor which we solder here, and further that goes on. So basically this whole project is based on a line follower board and a simple logic is formed that it have to work on a black line, and further according to that specifications and according to that mindset we form a truth table, and according to that truth table we apply a rudimentary logic on it, and by that rudimentary logic we form some equations that having a 7 8 input. So that 8 input is provided to the mux, and that mux will provide the input to the motor module, that either our motor will work left or either it will work right. So according to that our whole robot will work. And further, as I already showed you the mechanical robot kit, that is the here at which our circuit is patched, and this is the final look of our project here. I will show you. this is this is the final look of our project here. So we have attached a motor module here, the PCB layout at the behind here, the force sensor at the front, and the battery goes downward. We have stick them, and this is our robot will work. Thank you.